Hey folks, welcome to my channel Number Pen. So we have the problem on our screen. Determine whether the following function is differentiable at the indicated values. The function given to us is x mod x at x equal to 0, right? So let us rewrite the function because it looks like the function has a mod and we know how to treat these mod functions, right? And whenever you have a mod function, mod of x, let's remember that my mod of x is x for x greater than or equal to 0 and minus x for x lesser than 0, right? So what happens to my f of x then, right? So when I rewrite my f of x, I can I will have two functions, and for all x greater than or equal to 0, my mod x becomes x, so it becomes an x into x. And then for all x lesser than 0, my mod x becomes minus x, right? So I will still have my x and I will have minus x into x, right? So my first equation is for x greater than or equal to 0, and my second equation, which is minus x into x, is for x lesser than 0, right? So what is my x into x is nothing but x square. So I can comfortably write this as x square, and for x less than 0 I have minus x square, right? So this is how we write this equation x mod x. And now we've been asked to find the differentiability of the function at the indicated value. Our indicated value here is 0, right? That is our x naught is equal to 0. So like we did in our previous videos, we will start off with our RHD. So my RHD is f dashed of x naught plus, right? And in this case, my x naught is 0. So wherever I have x naught, I can comfortably replace it by a 0, right? So this is r f dashed of 0 plus, that is equal to limit h tending to 0, f of 0 plus h minus f of 0 divided by h, right? So my f of 0 plus h means x taking a value which is greater than 0 by an infinitesimal h tending to 0. So then we will have to go for x square, right? So my f of 0 plus h, we will have to pick up function x square and replace x by 0 plus h, right? So let me write it in the next line. So my f of 0 plus h is 0 plus h the whole square, because I'm picking up the function which is highlighted in yellow, because this is my right hand derivative, right? Bracket this and raise it to the power square. And then I have my f of 0. What is my f of 0? My f of 0 is again going to take the value x square, because for all x greater than and equal to 0, I'm sorry, for all values greater than or equal to 0, we have f of x equals x square, right? So my f of 0 is 0 square, which is nothing but a 0, right? So I have my h in the denominator. So my 0 plus h the whole square is nothing but h square, right? So I can call this as h square, which is my numerator. And then I still have my denominator h. So one h gets cancelled. I'm left with h, which is h tending to 0. So my RHD is nothing but 0, right? Let's move to our LHD. And what is our LHD? Our LHD is my LHD equals f dash of x naught minus equal to limit h tending to 0 f of x naught minus h minus f of x naught divided by minus h, right? So in this case, my x naught is 0, and I'm going to examine the differentiability at 0, right? So I can comfortably replace x naught equals 0, and then I I will have to consider which is that equation I need to apply when x naught takes a value 0, but this time it is x naught minus, right? And what do we mean by x naught minus? X takes a value which is lesser than x naught by an infinitesimal h, right? And that is why my x gets replaced by 0 minus h, which means my x is lesser than 0, and therefore I'll have to pick up this function which is minus of x square, right? So I will have to replace x by 0 minus h the whole square, right? So let me do that. And when I do that, what do I get? My first part of the numerator takes a value of 0 minus h into minus because I have it as minus x square. And then I have my f of 0, which from the RHT, which we worked out, is going to take a value of 0 squared. It's going to take x square. So it will remain as 0. And then I have a minus h in my denominator, right? So then I'm left with a minus h square in the numerator, and I'm left with a minus h in the denominator, right? So minus h square divided by minus h, I'm left with a h here, which is 0. And why is that? My minus sign in the numerator and the denominator gets cancelled, and I can pull out one h, and I'm left with h which equals 0, right? So here we have our LHD also tending to a finite value as h tends to 0. And let me highlight this. So I have my LHD, I have my RHD. So I have my LHD, I have my RHD, and the condition for differentiability is both LHD and RHD will have to exist, and they will have to be equal, right? So in this case, my LHD equals RHD, and it is equal to 0, and therefore the function is differentiable at x equals 0. 0, right? I hope you found this video useful. Please do subscribe to my channel and support. Thank you.